Hello again, and welcome back to another episode of Chemistry. It is all that matters, and today we're going to talk about chemical formulas. So chemical formulas, that deals with the language of chemistry. So how do chemists take those big words and turn them into a shorthand so that it is easier to communicate? So we are going to talk about how we take those chemical elements with their long names like francium and sodium and turn them into things like Na2SO4 and CaOH2 and H2O and NH43PO4 and don't forget rust, Fe2O3. So we all have a basic way of communicating, so we all agree on the same rules. We are going to talk about the language of chemistry and chemical formulas. So these chemical formulas are going to provide information. They're going to provide information about the compounds, the molecules that we are dealing with in our chemical reactions. And this basic information is include the elements in the compound, how many atoms of each element, and then how many molecules may be present when we are dealing with these reactions. So the elements involved, how many atoms of each element are involved, and possibly how many molecules could be present. So here's a typical shorthand version of a chemical compound. And what we have here, 2Fe2O3, and we've talked about this before. This is rust, Fe2O3. But basically, the first things we notice is the Fe and the O. That's the element symbols. So we know that this compound has iron, Fe, and oxygen, O. So this tells us what elements are involved in the molecule. Now, these little numbers, the subscripts, these are going to tell us how many atoms of each element are present. So for this, we will have 2 atoms of iron, and we will have 3 atoms of oxygen. So again, the subscripts tell us how many atoms of each element. Now the big number in front, from math, we know that is called a coefficient. Like in 2x squared, the 2 in front would be the coefficient. Now in this case, our coefficient tells us how many molecules are present. So basically what we're telling ourselves in this shorthand version is that we have 2 molecules of rust, or 2 molecules of Fe2O3. And then each molecule would have 2 irons and 3 oxygens. So let's review that. So the red number in front is the coefficient. The coefficient here is 2, and that tells us we have 2 molecules of iron oxide, or rust. The purple letters are the elements. And here we have an iron element, and we have an oxygen element. And then the subscripts, the little numbers, that tells us how many atoms of each of those elements are present. So for this case, we have 2 iron, 3 oxygen. So in 2 molecules of rust, we will have 2 times 2, 4 atoms total of iron, and we will have 2 times 3, 6 total atoms of oxygen. So basically, this is what we're looking at. Here we have 2 molecules of rust. Notice the gray circles represent the iron atoms. The purple circles represent the oxygen atoms. And since we have 2 of these, those represent the molecules. And each molecule has 2 iron and 3 oxygen, which gives us a grand total of 2 molecules of iron oxide with a total of 4 atoms of iron and 6 atoms of oxygen. Now the coefficient, or the molecule number in front, actually acts kind of like distributive property in math, where the 2 gets multiplied times each of the subscripts, and that's how we get the total numbers. When we look at 2 molecules of iron oxide, we get 2 times 2 to get 4 atoms of iron, and 2 times 3, 6 atoms of oxygen. So in your tutorial, you have a PDF that will let you work through this worksheet that we're going to go through right now, and we're going to do a little practicing in naming the elements in a molecule and figuring out how many atoms are present, and then we'll walk through another one where we talk about what that molecule number, the coefficient number, actually means. So if you've printed out the PDF, you can go ahead and start filling it in, and the first thing you're going to do is name each of the elements in this molecule of sodium acetate. So go ahead and do that. So for the symbol Na, that should be the element sodium. The C represents the element carbon. The H represents the element hydrogen. And the O is, of course, the element oxygen. So now what we're going to do is we're going to figure out how many atoms of each of those elements is present. So on your sheet, on the PDF that you printed out, please write how many atoms of each of those elements is present. So go ahead and do that now. So you should have 1 sodium, you should have 2 carbon, you should have 3 hydrogen, and 2 oxygen. So let's try another one. Here we have calcium hydroxide. Calcium hydroxide, go ahead and write in which elements are present in that molecule. So you should have calcium, Ca, oxygen, O, and hydrogen, H. So now we're going to count how many atoms of each of those elements are present in the molecule. Now what we need to understand is that the little 2 outside of the parentheses, and that little 2 tells us we have actually 2 units of the hydroxide, the OH, so that 2 gets distributed inside. So when you do your count, make sure that you distribute the 2 to the 2 elements inside of the parenthesis. So go ahead and do that now. So your answer should be 1 calcium, 2 oxygen, and 2 hydrogen. So let's look at this one. Here we have 3HNO3, and HNO3 happens to be nitric acid. So go ahead and first figure out how many molecules of nitric acid are present, then list the elements and how many atoms of each element are in a single molecule of nitric acid. We're not talking about the total right now. We're talking about only in one molecule. So go ahead and do that now. So the 3 in front is the coefficient. That tells us we have 3 molecules of nitric acid. Your 3 elements are hydrogen, nitrogen, and oxygen. H hydrogen, N nitrogen, O oxygen. And our atom count for a single molecule is 1 hydrogen, 1 nitrogen, and 3 oxygen. So how many total atoms are present of each of the elements in this molecule? Now we're counting all 3 of the molecules. So go ahead and figure that out. And for the total atoms present in all 3 molecules, we would have 3 hydrogens, 3 nitrogens, and 9 oxygens. So there's one more sheet on that PDF, and that PDF has this chart here. And I want you to do the atom count for each of the molecules present. And go ahead and turn off the video now, fill in the data chart, and then come back and see how you did. So let's see how you did. So here we have H2SO4, sulfuric acid, and in this case we have 2 hydrogens, 1 sulfur, 4 oxygen. For C6H12O6, you should remember that from biology. That is glucose. So there are 6 carbon, 12 hydrogen, and 6 oxygen. KNO3, potassium nitrate, 1 potassium, 1 nitrogen, 3 oxygen. Sodium acetate, NaC2H3O2, we have 1 sodium, 2 carbon, 3 hydrogen, and 2 oxygen. MgNO3, magnesium nitrate, 1 nitrogen, 1 magnesium, 2 nitrogen, and 6 oxygen. Remember to distribute the 2 to both the N and the O3. So that makes 2 nitrogen, 6 oxygen. C2H3COOH, also known as acetic acid, which is vinegar, we will have 3 carbon. Now there are 2 carbon in front, and then COOH has another carbon, so there are 3 total carbon. There are 4 total hydrogen, and there are 2 oxygen. And then the last one, aluminum acetate, Al, parentheses C2H3O2, close parentheses with a 3 on the outside. And again, distribute that 3, so we get 1 aluminum, 6 carbon, 9 hydrogen, and 6 oxygen. So hopefully you are able to count atoms in a molecule and figure out how many molecules are present, and we will talk more about how to put those compound names and symbols together in later episodes. So keep understanding that chemistry, it is all that matters.